Everyone. I'm Kiana Ehsani, co-founder and CEO of Vercept. I am very sorry not to be there today, but I am going to talk about my journey from academia to industry and what I learned building AI agents that use computers like we do. And I think I will unfortunately miss chatting and learning a lot from all of you at ICCV, but I hope you have a wonderful time in Hawaii. Um, so here is some of the findings that I've had in the past exactly 1 year of going from doing academic research to moving more to the industry side. And I thought this workshop would be a great location to basically talk about a lot of the findings that I've had. So at Vercept, we are building Y. The company is a group of AI researchers, and the goal is to build an AI agent that can actually use a computer the way that we do, moving the mouse, typing, clicking, and reading everything that is on the screen without any APIs, plugins, and no cloud check-ins. I really wish I could be there in person, but actually, that's the lesson number one. Once you move to industry, life gets a lot more chaotic, and you start juggling product releases, fundraising, talking to users, customers, and it gets unexpected. And sometimes that means missing events that you care about, but unfortunately, that's part of the trade-off. So today, I want to share what that transition from academia to industry really looked like, and not just in theory, but also in terms of what are the different types of techniques that we need to add to our toolkit in order to train a model and in order to basically be transfer the knowledge that we've learned from academia to the industry. Lesson one is the data reality check. It's very interesting because I think in academia, data is basically the playground. You either use public data sets or scraped away web or just convince an undergrad that is working with you to help you annotate data. It's cheap and noisy, but it's good enough to prove an idea. It's good enough to prove a point. In industry data, I think it's a very good way of putting it. Data becomes a currency. The quality of it and freshness of it matters more than quantity. And time not is actually the scarcest resource, and like it's actually very important to move fast. So you're often racing to validate a hypothesis before the market and the competition gets to that. So that's why it's easier to make more expensive decisions, but it needs to be more quality focused, and less time for experimentation with that. When we started Vercept, for example, we realized that for computer use agents, internet data wasn't enough. You can't learn how to use, for example, like Excel or Photoshop by just reading Stack Overflow. You need real world interaction data, and you need to actually have agents or annotators like actually play with the data on the screen. So one of the biggest outcome, in my opinion, is that forced us to obsess over data quality and curation. We spend hours and hours just cleaning data, understanding the UI transitions, and removing biases from the data. And the result is that our models learn these patterns and it can generalize to more robust behavior rather than just some demos. So I think the lesson learned on the data side is that data defines your ceiling. So in academia, it defines more your insight, but in industry, it actually defines your survival. That's why a lot of the companies, the data that they collect becomes one of the assets of the company. And next one is training. So after you collect the data, you start training the model. The difference is that you are when you are running academic training runs, it's more exploratory. You are testing a new loss function. You are you're looking at training curves. You're trying to understand why something works. In industry, it's actually a little bit flipped. You want it to work every single time. The recipes are known. The challenges are that you need to build a system that is reliable and it's speedy and it's cost effective. Um, so we learned that most innovations basically don't come from architecture. It sometimes comes from constraints. We train models that must be fast in inference time because when you are doing computer use, the inference time every time is matters a lot. So every parameter is a cost on user experience. Every millisecond of delay that we have will be reflected on the data. So that's something to also note that um that the lessons from staying lean and like training smaller models from academia is actually very impactful when you've spent years having to fight over GPUs and not being part of a big lab but like an academic lab. You actually learn how to be more efficient, and efficiency basically becomes second nature. The next one is inference. So we collect the data, train the model, now it's inference. Inference is where the work actually starts. Inference is barely mentioned in academic papers, or maybe just the one line that says we run inference on test data. Um, I know that more and more these days, like people are thinking about, having demos, but in production, it's actually inference is part of the product. Inference is part of the work that you're doing. The latency, the memory, the security, and the UX all depends on it. So with why inference and hosting our models was actually one of the big part of the project. That means that how to manage the server load, how to make sure that the data is encrypted to go to the server and the inference is done. It's been very important for us. And I think the lesson learned here is that in academia, you stop when the model converges, and in industry, that's actually where the second phase of engineering begins to make sure that these models can be run efficiently on the cloud. The other one is the evaluation. I think evaluation is where academia is actually a lot ahead, and industry is actually piggybacking on top of academia. Academia values benchmark, ImageNet, MMLU. These are all some of the greatest gifts that we have given to industry. And it's funny that I'm using the word given that I'm on the dark side now, but I think it's actually like one of the most important things that industry doesn't appreciate enough. Most companies underestimate evaluation and they measure, engagement, but not real capabilities. And it's actually, we learned this that it's very easy to think that your AI works and like, doing vibe checks, but testing on real evaluation benchmarks is actually how you can make a lot of progress in industry. Um, at Vercept, we actually built our own suite of evaluation environments. We have toy tasks that are like more for simple activities. We want to make sure that the model is capable of doing clicking and form filling and like basic activities. Then we have controlled environments like mock web apps that is basically mimicking the behavior of the real world in some like simpler controlled environment that is deterministic, so we can evaluate the models in a deterministic way. But we also have benchmarks that are real world applications and real world use, for example, using Chrome, using Excel, and even OS level actions. And this is very important because each one of these categories actually brings a different value. Um, there's like a trade-off between the determinism versus more like having more noise in the evaluation that you have. But at the end of the day, because the product is going to go out, you have to have those real world benchmarks that the variability of them are higher because the environment is constantly changing. It's a real environment, but it's unavoidable. And I think this hierarchy is also like mirroring how we evaluate our models. We just start with simpler tasks and then we evaluate on the real world setups at the latest layer. And I think the lesson learned here is that evaluation is never done, and it's the heartbeat of real progress. Um, the next one is great. So we did the evaluation, we did the data collection, training, inference, evaluation, and it's time to convince people, also known as reviewers, why this work is effective. In academia, your audience is reviewers. You write, you argue, you hope someone reads the supplementary PDF. You talk about baselines, you talk about argue about limited novelty. In industry, it's actually very similar. Your audience becomes investors, customers, and teammates, but the rest is again convincing, comparing with baselines. The novelty becomes like the moat, like basically like the same concept of there's limited novelty will become like there's limited moat. So a lot of it is very similar, but I think I realized that when we were raising our seed round, I realized that actually pitching to investors isn't so different from writing a paper. You're still proving novelty, impact, credibility, but it's just a different vocabulary with people that are less technical and don't speak your language as much. And when we launched the product, when we launched Y, then user feedback replaced the peer review. So instead of accepted to CVPR, we say, oh, this product saved a user 4 hours today. So it's like it feels very, very similar. But I think the lesson here was that the storytelling skills that you learn in academia is actually going to be your secret weapon in industry as well. I think the next topic, which is success metrics, is a very important one, and it's actually very different from academia to industry. In research, if something works 20%, then it's great, new finding. If it works 50%, then great, it shows signs of solution, and those are your first signals. And and finally, if it's something gets 80% in research, then you've solved it, and you basically move on to the next problem. In production, 80% is basically broken. You even don't talk about it. And the success rate that is needed is 99.999%. And honestly, that final 20%, the long tail, is brutal. It's messy data, it's corner cases, it's weird user setups, and that's where reliability, trust, and then most importantly, reputation lives. Um, why can't afford to almost click the right button. If it fails 1 in 100 times, users stop trusting it. So we have spent months of building systems to detect these uncertainties, recover from mistakes, and learn from failures automatically to be able to gain the trust of our users. I think the very important lesson here is that academia celebrates for success that comes with that innovation. Industry requires the consistent success that is repeated over and over again. Um, great. So you come to the last stage. The success metrics are there, and everything is there. So that should be done, right? So I think this is where basically like the process from going a paper to a product, in my opinion, looks like. In academia, your goal is to publish and move on to the next topic. In industry, it's more the work just starts after you ship, and you can't just move on to the next topic because there are now users that are depending on this. So you have to constantly iterate on what you have built. And I think shipping Y was actually taught us that um, robustness, design, user trusts are worth as much as any model breakthroughs. And users don't care how you have trained the model, how different your model architecture is. They care about how reliable it feels. And making something more reliable doesn't always come from all on the model training side being um, more robust. Sometimes it's also in the infra. And I think they product basically, they say product lives or dies on love, and that's the difference between usable and used. And I think um, one of the lessons here is that the difference between academia and industry here is that in academia you are basically like optimizing for citations, for making something novel that can be applied to many different topics, and like you show that this is true. In industry, you actually optimize for robustness and reliability, which can also translate to user retention. The next one is I just want to talk about the hidden advantages of academia that I don't think people appreciate as much. Um, very happy that I started in academic research labs before moving to industry. And I truly believe from the bottom of my heart that moving from academia actually gave me some superpowers that many of the other people don't have. Having the lean mindset, learning to do more with less is one of the biggest gift from academia. It just makes your mind more creative and learning to what to do with limited resources. The other one is quantitative intuition. You measure in academia, you measure everything from the model improvement to data. Like you measure everything quantitatively, and that you can translate that to industry with from user engagement to latency and hyperparameter tuning. Um, you will have respect for benchmarks. That respect for benchmarks is one of the biggest gifts because it prevents you from falling into some loopholes or having regression in your product because you are relying on those consistent benchmarks that lets you hill climb and constantly make the product better and better and make the model that is in production better and better. And then I think the last one is basically having that curiosity without ego. You're constantly staying open to being wrong. You're constantly looking out to find ways to improve the product, and that's a great lesson as well. Um, and I think if I want to just dive into a little bit more details of training computer agents, which I know it's becoming more and more of a hot topic, we can just zoom in a little bit about core challenges behind why and how did we train a model that enables the product. Um, the reality is that you can't just rely on passive data. You need visual understanding, you need action grounding, and most importantly, you need temporal memory. So I don't think you can think of computer agents and training them just as the next token prediction. There are a lot of elements that goes into it that makes this problem a lot more complex. Um, and we found that basically there are a lot of insights in like having synthetic data, but real world data is also very important, and having the feedback loops and being able to teach the model the error recovery is one of the most important things in training these robust models. Um, and to dive a little bit deeper into the evaluations that we have, evaluating agents is much harder than evaluating image classification. There are a lot of metrics, and it's like also different than training evaluating it may be a like a language model. There are multiple different metrics. There is no single metric. You have to have tasks, durations, error recoveries, and for that, we have actually um, built a lot of different environments to test these core skills. You want to make sure that if you are building a horizontal model, a model that is has a lot of different capabilities, you want to know what are the limits of it, and you want to know. What are the ways that it fails, and what are the ways that it succeeds? And for that, you need to basically categorize your evaluation in different sets of skills, and also evaluate the models in more of a higher level domain, as I mentioned, like in real world applications that requires interacting with multiple one of these vertical skills. So, for example, like the task that we have, like might include one task might include interacting with an email, getting a file from the email, using the browser to find some information from that file and input it into spreadsheets. So I think that's one of the things that a lot of the benchmarks in the academic community for AI agents don't actually cover that, and they're more like single application, and it would be great to have more cross application benchmarks as well. And I think the um, final lesson, in my opinion, is the that mindset shift. Um, that there's a lot more accountability when these models are trained for the industry. It actually becomes liability when the model is running on real machines, it's touching real data. Then privacy and safety is very important. It's not a research project anymore. So that's why. We really wanted to basically push Y to be as local as possible and only send the data that is absolutely required to leave the device. And our vision is to basically like train the models in a way that distill the make the models smaller so that they can only fit on the device, and be able to protect our users. And there's also this great question to think about that what do we think about accountability? If an AI agent takes an action, who's responsible? Is it Y that is responsible, or is it the user that ran the AI agent that is responsible for that? Um, so with all this, I just want to end this conversation, or end this talk, um, talking about how much I've enjoyed this process of uh, having this hybrid mindset. I think academia teaches you how to think, and industry maybe teaches you more how to deliver. And the real magic is to just find the use all the findings from one mode of thinking to the other. And if there's one thing that I hope you just take away is that the boundaries between research and industry is actually fading. The best founders that are working out there, they are really the ones that are treating the ideas and like products and industry like experiments, and uh, always like measure everything, always improve everything, and have like very quantifiable ways of measuring the progress. And if you ever build something new, whether it's a model, it's a paper, it's a company, just remember that the hardest problems are usually the ones that are most worth solving, and it might not be an easy path, but those are the hard problems are the ones that are worth putting the effort on. I hope you enjoy the rest of your time in beautiful Hawaii and reach out if you want to chat.